Good language style can make it easy for the machine to compile the code into the thing you actually wanted it to execute. And it can also be a very cost-effective way to find bugs automatically. You should start by adopting a safe coding style, considering either MISRA C or CERT C or a combination as your starting point. Your project coding style guides should specify one or more static analysis tools and the configuration settings, even if it's just GCC plus a dozen or two warnings passed minus WAL. This will let you automatically check language-specific coding style and avoid wasting time on that at peer reviews. Once you have static analysis set up, consider adding dynamic analysis for even better defect detection. As with human coding style, the point of good language use style is to avoid bugs. Let the compiler help you by finding the bugs automatically before the humans even look at the code. There are some pitfalls for coding style. The first pitfall is thinking that just because the code passes tests, all those warnings don't matter. You might be passing tests because your tests are very weak, because you got lucky, or because, in general, this particular version of the compiler just happens to behave the way you need it to. Next, beware of real bugs that are found by the static analysis tools, but you don't see them because they're lost in a sea of warnings of things you decided were false alarms. An important reason that your code should compile clean is that you might not notice a new warning pop up if it's buried in thousands of other warnings. So it's better to compile 100% clean to avoid this. Finally, make it a bit painful to deviate from style rules. This is because if it's easy to deviate, you'll find that everyone has an excuse to deviate rather than spend the slight extra effort to clean up the code. Every deviation should be formally documented and should result in the code still compiling clean.